Yes, good evening, Adesha. Till what we discussed, 1 second. Have you learned, sorry, have you gone through the exam today?
No, sir. I was facing login issues, sir. I talked with Manoj, sir. He said to reset.
Okay. One second, let me put a message. Yes. So till what we discussed, what relation?
Transitive relation.
Transitive relation, right? So today we'll be talking about equivalent relation. Let's talk about that. So next type of relation is equivalence relation. Okay. Equivalence relation is nothing but what? See, agar ek relation, any relation is asymmetric, reflexive, as well as transitive. So that is an equivalence relation. What is that? Let me write here. Am I sharing the screen? No. Yes.
No, sir. It's not.
Equivalence relation में क्या होता है? See, basically, if a relation before this, beta, just let me tell you one thing. Before this, we have to discuss two more points. Note, I was trying to give note, right? I was trying to give you note yesterday, but we stopped the class. No problem. Notice, look at it, doublets. Always passes the transitivity. Okay. Next, if a relation is not transitive, even in a single case, then that particular, then that old relation, right? Then that Whole relation not a transitive. This is what this is also will end. Okay, isn't it? Huh. Now we'll go with the equivalence. Equivalence relation. Okay, equivalence relation. Equivalence relation is nothing but if a relation. Can you hear me, Adesha? Clearly? Kim said A
Yes, sir, you're audible.
is reflexive, symmetric, and transitive, then it's an equivalence relation. Then it's an equivalence relation. Okay. Huh. So in equivalence relation, what we learn here is write this very important note. Identity relation and universal relation. Look at this. Always an equivalence relation. Why they are always equivalence relation? Because identity and universal relation always what? Reflexive, symmetric, and transitive. Isn't it? Getting my point? Adesha, why they always an equivalence
Yes,
relation?
sir.
Why? Because identity and universal relation हमेशा क्या होता है? Reflexive, symmetric, and transitive. They always passes these three type of relations. Correct? Yes. Next, if you want an example, you can write an example like this. If set A is equal 1, 2, 3, let write a relation called A cross A. Relation, we write like this: relation is equal 1, 1, 2, 2, 3, 3. Now, what type of relation is this? This is an identity relation. Identity relation. Okay. This identity is always, whatever the relation I gave you, that is an identity beta. That is always an equivalence relation or not? Check. This is always equivalence relation. Why? First of all, this is an identity. Reflexive or not? Yes. It's reflexive. Symmetric or not? Yes. Yes. Whether it's a transitive or not? Yes. Just now I told doublets always passes transitivity. So if these three relations are it is, so that is an equivalence relation. Getting my point? Very simple. Understood? Yes.
Yes, sir.
Now, if I give any relation like the A cross A relation, if I give any relation, let's say I'm giving you like this. A cross A. What is the meaning of this? I'm talking about universal relation. Universal is an identity or not? No. Universal can't be an identity. But this is universal relation, right? Universal can be always reflexive. It can be always symmetric. It can be always transitive. Okay. If all these are satisfying, then it becomes what? It becomes an equivalence. So from this note, What we learned from the note? Identity universal relation always satisfies what beta? Equivalence. So this is an identity relation. It was always equivalence. It is an universal relation. It is always equivalence. Getting my point? Understood?
Yes, sir. Yes, sir.
Yes. Next. Just a minute. 1 second. I think is there anything that we are missing with? Let's check. No, I think absolutely fine. Now this is the time to move for the questions, I think. So types of relations we learned. So we'll talk about questions now. Equivalence relation, yes, we learned. And now let's talk about the questions, beta. See, questions are going to be very simple. Very means very simple. So let's solve couple of your NCRT questions, then we'll go for JEE questions. Okay. See, this chapter is not that much important for your JEE exam also. But in fact, okay, you may get one question or like, something like that. Clear? So if you have,
Yes, sir.
let me solve one question, beta. Look at this. So determine, question is determine whether each of the following relations are reflexive, symmetric, and transitive or not. The relation given to you here is comma y such that y is equal to x plus 5 and x less than 4. Here you write one important point. Relations are in set A is equal to 1, 2, 3, 4 till 13 comma 14 defined as like this. Now tell me whether it is a transitive, reflexive, symmetric, transitive or not.
Sir, it is not reflexive, not symmetric, and not transitive also.
It is not.
Sir, three of the conditions are not applied, sir. It is not reflexive, not symmetric, and not transitive, sir, because x is less than 4.
Yes, very good. None of the relations.
I got the relation as 1, 6, 2, 7, and 3, 8.
True. Yes. So you got the point, right? Very simple. So this is what given. Let me write here. So first of all, मुझे like I'll tell you how to write this. I'll tell you the way of writing in your board exam, how to present in your board exam. Okay. Okay. One second. Okay. First of all,
So
write.
first we should write what is given.
Yes. So y is equal to x plus y. Okay. So what he has given here?
The relation
Beta, look at
defined
this
as
here. You
x,
write.
y is such that.
Yes. Actually, in a set, I should give you like this. I think this is not. Okay. Even yes, you are right. Even you take this is a right. If I change the question, the relation R in a set n, set n is nothing but natural numbers. N of natural numbers defined as like this. Okay. So R is going to be what beta now? If x is equal to 1, y is going to be 6. Correct? And now you have to take x less than 4. This condition is given to you. Whatever the x value you have to take, x is equal to 1, x is equal to 2, x is equal to 3. That's it. So when these are x values, what is the y values? If x is equal to 1, y is 6. This is one order pair. If x is equal to 2, y is 7. If x is equal to 3, y is much 8. Correct? Yes. So this is what I got. So first of all, what is this? Whether it is transitive or not. So reflexive or not. Let's check reflexive. So what you have to check, you write like this for, you have to write an exam like this, but for reflexive. Okay, for reflexive. Straight away you can see. R is not. Directly you can write like this. R is not reflexive since 1 comma 1 is not belongs to R. Correct? For reflexive, 1 comma 1 double should be the right. If I take any ordered beta, okay, that shouldn't be, that should be there, but it is not available. So if I take 1 comma 1 should be there. If I take this case 1 comma 1, if I take this 2 comma 2 should be there. So that's why I'm saying it is not an ordered pair. I mean, that is not a reflexive. For symmetric, for symmetric, R
It
is
is not symmetric also.
not symmetric. Why? Since 1 comma 6 is
Since
belongs
1, 6 belongs to
to
R, but 6, 1 does not belongs to R.
6 comma 1 is not belongs to R. Very good. Okay. For transitive, look at this here. Here, look at this here. I need for
Sir, yes, sir.
for transitive what I need beta. For suppose, look at this here. If I take this as a comma b beta, so my b should start with somewhere 6, but nowhere is it is available. So it is not a transitive. Understood my point? No,
Yes, sir.
it's not available. So So here R is not transitive. Okay, so basically here what is the condition? If A comma B belongs to R and B comma C belongs to R, then A comma C should be in R. That is transitive, right? So if you take any one of the relation A comma B, which is 1 comma 6, but B, like no B's are same here. If you take this as 1 comma 6 beta, but here B and B should be same, but nowhere we have something like that. So we will not be checking, it is not a transitive. Very simple. Next, once again, let me write a question. See beta, one more question, let me write. Same type of question, let me write here. The question here is x comma y on set A defined as x comma y such that 3x minus y is equal to 10. This is a relation given to you. Check whether this is a transitive, reflexive, and symmetric or not.
Sir, you wrote 3x minus y is equals to 0 or 10?
Sorry?
Sir, in the question, 3x minus y is equals to 0 or 10?
0, 0, not 10.
Yes. Sir, same situation, sir. It is not reflexive, not symmetric, and not transitive also.
Sorry?
Sir, same as the first one, sir. Not reflexive, not symmetric, and not transitive.
Yes.
I got the relation as 1, 3, 2, 6, 3, 9, and 4, 12.
Yes, yes. So first of all, let us write the order pairs. What is R here? If x is equal to 1, so first of all, you have to take this as 3x is equal to y, right? If x is equal to 1, what is y? 3. If x is equal to 2, y is 6. X is equal to 3, y is 9. If x is equal to 4, y is equal to
Y is 12.
12. If x is equal to 5, y is equal to 15. But we will not
50,
be going for
not
this.
possible.
Why? Why? Because we don't have
Set contains only 14 elements.
till 14 only. So this ordered pair is not going to possible. So we'll be writing till 4, 12 only. Okay? Yes. Now, so beta you are here A comma B hai na? Whatever the A comma B are, that should be belongs from set A only. So you can't write like that. So now check for see whatever however I wrote here, you have to write everywhere like that only. For getting good marks, for getting full marks, you have to write like that. So I'm writing direct here now. Okay, so reflexive or not? See, ordered pair, there should be an ordered pairs. Look at this, 1, 1, 2, 2, 3, 3, till 14, 14, every doublet should be there. So it is not a reflexive. Okay. We don't have doublets here, right? It is not a reflexive. Symmetric. Check one case. If we take this as A, B, 3, 1 is not available. So it is not a symmetric. Transitive. In bracket, you can write beta since this is the reason. Since this is the reason, you can write in bracket. Okay. If I take for transitive beta, if I take this as A, B and B, C should be this B, C. But what 1, 9 is not
1,
available.
9 is not there.
So not a transitive. Very simple. Correct. In bracket, you can write the reasons. Since, let me write for this. Since A, B, since 1, 3 belongs to R and 3, 9 belongs to R, then 1, 3 must 1, 9. 1, 9 is not belongs to R. So it is not a transitive. Okay. What is the meaning of this into? They are not that particular relations. Okay. Next. Now I'll give one simple question. Relation in R set A that relation in a set A that 1, 2, 3, 4, 5, 6 as given that R is equal to X, Y such that Y is divisible by X. Y is divisible by X. Make it fast. First of all, I'll be writing myself. You write yourself. Okay. So first of all, tell me what is ordered pair is going to be. You tell me that alone. After that, you can identify very easily. First of all, Y is divisible by X beta. Y is divisible by X. So 1, 1, 1, 2, 2 is divisible by 1, 1, 3, 1, 4, 1, 5, 1, 6, and with the 2 you write 2, 4, 2, 6, 3,
So then 3, 6.
3, 6, 4, 4, 5, 5, 6, 6. Only these are the possibilities, isn't it? Y is divisible by X here, beta. Therefore, Y 1 is divisible by 1, 2 is divisible by 1, 3 is divisible by 1, 4 is divisible by 1, 5 is divisible by 1, 6 is divisible by 1, 4 is divisible by 2, 6 divisible by 2, 3 is divisible by 2, like that. Understood my point? Yes. So Y is divisible by X is nothing but this is how we just write. Now we will check whether it's a reflexive or not. Reflexive or not. Reflexive on doublet should be there, beta. Doublets is nothing but 1, 1, 2, 2, 3, 3, 6, 6. Everything should be there. 1, 1 is there. 2, 2 is there. This 2, 2. 2, 2 we missed. 2, 2 we missed. 2, 2 should be there. 3, 3, 4, 4, 5, 5, 6, 6. Now tell me whether it's a reflexive or not. All doublets are available, so it is a reflexive. Other than doublets, anything is possible, beta. Anything can come, anything may come, may not come. So 1, 1, 2, 2, 3, 3, 4, 4, 4, 5, 5, 6, 6. All doublets are available, so reflexive. Symmetric or not? Symmetric or not? Symmetric or not? Check.
The doublets are there, sir. But if
Because
1,
if you take this as,
2 is there, 2,
yes,
1
yes.
is not there, sir.
If you take this as a comma b, 2, 1 should be there. 2, 1 is not there, so it is not a symmetric. Isn't it? Transitive or not?
Yes, sir.
Transitive?
Not transitive, sir. 1, 1 is there, 1, 2 is there, but 2, 1 is not there.
1 second, let's check. So this is a comma b. B comma c should be what? Let's say this is b comma c. Then 1, 4 should be there. 1, 4 is available. Okay, let's take this as a comma b. B comma c is what? Let's say this is b comma c. Then a comma c is 1, 6 should be there. Yes, it is there. Okay, let's take this as a comma b. And b comma c should be what? B comma c. This is b comma c. Then 1, 4 is there. Right? It is a comma b. Take this. But it is transitive. It is transitive. This is 100% transitive. Okay, understood my point? Is it clear? Understood or not? Is it clear? Understood my point? Understood my point, Adesha? Hello? Are you here? Are you here or not? Hello? Adesha, can you hear me? Hello? Okay, I think you have some issue. No problem. So next question, let me write next question. Next, fourth question, let me write something like this. Yes. Are you here? The first question is relation given to you that x comma y such that x and y work in the same place. Tell me whether it is a symmetric, reflexive, and transitive or not.